Okay, let's get started with section 2.3. So up until now, in chapter 2, we've done a little bit of math, but not much. We have spent more time with graphs. Now we're going to start getting into the nitty-gritty of descriptive statistics. So let's start by looking at mean, median, and mode. Mean, median, if I can spell, and mode. So we're going to talk about the mean first, because I'm mean like that. The mean of a data set is the sum of the data entries divided by the number of entries. Now, that's the formal definition. Sometimes people get caught up on terminology. You're like, if I ask you what's the mean of this data, or how do I find the mean, you're like, well, I don't know what the mean is. But then I'll say average, chances are you're probably not going to give me the definition that I just put on the screen. What are you going to say? How do you find the average of something? The way we commonly say that is you add them all up and divide by how many you have. That's exactly what this definition is saying, just in a more formal manner. So for mean, we add them all up and divide by how many we have. Okay. I don't like that. I'm trying to get a good heading. There we go. Good enough. So now there comes two formulas with mean. There's two formulas that we need to look at when we're talking about mean. And these formulas are going to be on your formula sheet that you'll have on your test. So you don't have to memorize them, but you do have to know what they are. The first one will say mu equals the sum of the x's divided by capital N. And then you'll see one that says not mu. You'll see one that says x bar equals the sum of the x's over lowercase n. Now, let's talk about what all these symbols mean. That mu that stands for the population mean. Similar to that, x bar stands for the sample mean. And we say this like mu. M-U. Mu. Like, not moo, but mu. Anyways. Those are the formulas. And they are on your formula sheet that you'll get on the test. This formula sheet is in Blackboard. If you're in an in-person class, I'll print one copy for you. If you're doing this online, you can print a copy of this and use this on your test. Some of the formulas we've already talked about on here. We talked about range. It's just the max minus the min. Class width was section 2.1. Midpoint. I didn't realize that one was on there. So we've talked about those three already. Now we just mentioned two more. X bar, sample mean, and mu, population mean. Okay. So now, let's do some stuff with this, shall we? So So example number 1. Let's see what example 1 holds. Weight in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? Okay, so when you do these, I like you to write down the formula that you're going to use first. Before you do any calculating, let's write down the formula. So how can I tell? Well, they want the mean weight, so we know it's going to have to be x bar or mu. But then we talk about a sample of adults. A sample, and they want mean weight. Which one is sample mean? It's going to be the x bar. So we're going to write our formula down. X bar equals the sum of the x's over how many we have. Let's do that. 274 plus 235 plus 223. Now, if you have 20 data points, you don't have to write them all down. You can put plus dot 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 and then write the last one. And what that tells me is you know you got to keep adding them all up until you get however many there are. Let's see, how many are there? What's our n here? 1, 2, 3, 4, 5, 6, 7. So n equals 7. So we divide by 7. Okay, let's add them up. So we're going to have 274 plus 235 plus 223 plus 268 plus 290 plus 285 plus 235. So we should get 1810. 1810. Divide that by 7. So divided by 7. 258.571. Okay, so when we deal with statistics, we typically round one more place than the data is given. So they give it to us to the nearest ones, so I want one decimal. I'm going to round that to 258.6. So the mean is approximately 258.6 pounds. And that's our answer. That's the mean here. 258.6 pounds. Notice I put my units on there because I don't want this to be some mystery as to what units there are. It's in pounds. Okay, so that's all mean is. You add them up, then divide by how many you have. Now, there's something else that we can look at, and it's median. So I'm going to come in here, we're going to do another definition. The median of a data set is the value that lies in the middle of the data when the data set is ordered least to greatest. So that's our median. Now, if the data set has an even number of entries, then the median is in the middle. That's honestly what this position is talking about, n plus 1 over 2. So on our formula sheet, that position formula is talking about how many entries there are. You add 1 to it and divide by 2, and that kind of gets you your middle entry. But I don't like using that formula. That's what it means, but I don't like using that formula. So I like to remember it this way. So if there are an odd number of entries, the median is the middle data point. If there's an even number of entries, the median is the average of the two middle data points. So what does this tell you? This tells you all data sets will have a median. So I covered all the bases. If I have an odd number of entries, boom, it's in the middle. If I have an even number of entries, I take the middle two and I find the average. So it's still in the middle. All data sets will have a median. With that said, all data sets have a mean. Okay, so let's look at example 2. Example number 2. They want us to find the median, I can't spell, of the weights listed in example number 1. That's all it says. Okay, so what do we have to do first to get a median? We have to order the data least to greatest. So I'm going to leave example 1 up here on the screen so I can put them in order from least to greatest. Looks like my smallest one is 223. Then I have 2 of them that are 235. Then I have a 268. I have a 274. A 285. And a 290. Okay, so to get the median, I go to the middle entry. You can count and say, oh, it's odd. Okay, whatever. What I like to do is I like to cross them out. Boing, 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 boing. There's my median. That's a terrible box. Let's try that again. Here, there's my median. So the median is equal to 268 pounds. Done. Okay? So obviously that one had a odd number of entries. It made it easy. Now, let's look at example 3 that tells us In the previous data set, the person who weighed 285 pounds backs out of the study. Find the new median. Or let's word it a bit. Same thing, but what is the new median? There we go. Okay, well, same process. I already have them in order, so I'm just going to copy them down, but now the 285 person is out of the picture. So I'm going to have 223, 235, 235, 268, 274, 285 is gone, they dropped out of the study, 290. And then I go through and say, okay, which one's in the middle? Cross out, cross out, cross out, cross out. Uh-oh, I only have 2 left. So I need to get, if I cross them out, there's nothing left. I need to figure out the middle right there. So the median was equal those averages. So 235 plus 268 divided by 2. Okay? 235 plus 268 divided by 2, 251.5 pounds. 251.5 pounds. That's my new median. Okay. So that's how we do it with an even number of entries.